more about ratios, proportion, and similarity of triangles, and also about special right triangles. So for the first one here, okay, we have common examples of ratio and proportion in popular culture. So like we have here on Demon Slayer, we have here Zenitsu and Tanjiro sharing a rice cake. So there you go. That's one example that we can see in popular culture on how we can use ratio and proportion in terms of sharing. And also we have here Sasha Browse when she tried to hide the meat, okay, for his teammates, and also she will share the meat in the future with his team members. So that's one way of showing ratio and proportion in popular literature. And also in real life, you guys can also think of more applications of ratio and proportion, not just confined within friendship, but also expounded into our nation and also to our communities. So we have here a common example of a ratio. So a ratio is just simply a comparison of values. Okay, so we have here a boy and a girl. Okay, so let's say for example, we want to compare the ratio of, let's say for example, in a room there are 3 boys and then there are 4 girls. So therefore the ratio must be 3:4. And then if we have to compare that value 3:4 to another ratio, or if we have to equate that, so that's going to be a proportion. So that becomes, if we have here 3:4 as our first ratio, then we're going to have here, okay, let's count 1 2 3 4 5 6 blocks, okay, for the green one, and then 1 2 3 4 5 6 7 8, so 8 blocks for the blue one. So therefore we have here an equality of fractions and also an equality of values that we try to compare. So there you go. So that's why we have here a proportion. A ratio is a comparison of values. A proportion is a equality of ratios. So those are some key terms to remember. Okay, so ratios can be written into 4 different types. Okay, so we can write here A is to B, or A double dot B, or A over B, or A/B. So all of these 4 just typically connotes that we have here 2 values that are being compared to. And if you've seen most likely you've seen proportions also in different problems. We commonly use cross multiplication, okay, to solve for the missing values of a certain variable in a given proportion. Okay, so let's try to identify the parts of a proportion. So we have here, okay, so if we have here, let's say for example, A over B is equal to C over D. Therefore, A and D, okay, so A and D, we call those as extremes, okay? And then B and C, okay, so we have here B and C, so we call those as means. Okay, so we have here A and D, so those are extremes, 7 and 30. And then we have here B and C, so 14 and 15, those are our means. Okay, so 7 and 30, A and D, so those are the extremes, 14 and 15, those are the means. And the means and extremes proportion theorem, so in a proportion, the product of the extremes is equal to the product of the means. So that means A times D is equal to B times C. Okay, so let's try to solve for some variables here, or for some problems. Let's say we have here a proportion 4:8 is equal to 16:T. So we can transform that into a fraction. So 4/8 is equal to 16/T. So from this, you can already deduce the value of T ahead of time by multiplying the denominator by 4. Okay, so you're going to get T is equal to 32. Is that right? But let's try 2. Okay, so let's just keep that in mind, that T is equal to 32. And let's try to solve it using cross multiplication. So therefore, we have here 4T. 4T is equal to 16 times 8. Okay, so 16 times 8 is 8. Carry 4. Okay, so that's 108. Okay, or 128 rather. Okay, so that's 128. So 4T is equal to 128 divided by 4 for both sides. So therefore, the value of T is equal to 32. Okay, so there you go. So our initial assumption and our computed answer both match each other. Okay, so let's try this one. So we have here 7 over t is equal to 21 over 294. So for this one, it's already written in a fraction form. So you just have to solve for the value of t. So this one is going to be very simple. Again, we can use cross multiplication. So this becomes 7 over t is equal to 21 over 294. Okay, so using cross multiplication, we have here 7, okay, 7 over 7 times 294 is equal to 21 times t. Okay, so this simply becomes, okay, so therefore we get 2058 is equal to 21t, and then when we divide both sides by 21, so therefore the value of t is equal to 98. Okay, so that's simple by using cross multiplication. And this has been taught to you also in the 6th grade and also in your elementary years. So this one is quite of a bit of a review and also a preparation for your future topics here in our 3rd quarter. Okay, so we also have here the concept of a geometric mean. So how do we get the geometric mean? So let's say, for example, we have here two ratios, because we have here A is to B and B is to C. Okay, so let's say, for example, we have here 4 is to 5 and 5 is to 6. So this is kind of like what it's saying here. So therefore, to solve for the geometric mean, the geometric mean would be B is equal to the square root of the product of A and C. Okay, so how do we get this? Okay, so from the ratio that we have here, we can write a proportion for that. So it's going to be A over B is equal to B over C. Okay, and from here we can use again cross multiplication to get the value of B. So this will become B squared is equal to AC. And then we square root the both sides of the equation so that we get the value of B is equal to the square root of the product of A and C, or square root of A times C and its square root, or the square root of the product of A and C. So that's the value of B. Okay, and we call this equation as the geometric mean. Okay. And to solve for the geometric mean of any given number, we just input the specific function. So let's say, for example, we want to get the geometric mean of 4 and 6. So to get the geometric mean of 4 and 6, so we get that B is equal to 4 times 6. Okay, the square root of 4 times 6, so that's going to be square root of 24. And if we factor this, so this is going to be 8 times 3. Okay, so this can be simplified as 4 times 2 times 3. So this will give you 2 square root of 6. Okay? So therefore, the geometric mean of 4 and 6 is 2 square root of 6. Okay? So that's simple. Okay, so of course, for proportion, we have the different properties of proportion that make them unique. There are 6, okay, that we're going to use widely or apply widely on our different topics for proportions. But for the first one, we have here the invertendo. So the invertendo property of proportion states that if A is to B is equal to C is to D, therefore A is to D, B is to A is equal to D is to C. Okay, so to write that in fraction form, so let's say, for example, A over B is equal to C over D. Therefore, B over A is equal to D over C. It's kind of like just inverted. Okay, so from this initial assumption that we have here, we inverted it to this type of proportion. Okay, so for an example, we have here 3 is to 4 is equal to 45 over 60. And therefore, if we invert it, therefore 4 over 3 is equal to 60 over 45. And if we want to write it as a fraction, or as a ratio using the double dots, so this can be written as 4 is to 3 is equal to 60 is to 45. Okay, so we can also think of another example. 1/2 is equal to 25 over 50. And using the Invertendo property of proportion, we can say that 2 over 1 is equal to 50 over 25, or 2:1 is equal to 50 is to 25. So that's the Invertendo property for you guys. Okay, and then we have the Alterando. So the Alterando property of proportion states that if A is to B is equal to C is to D, then A is to C is equal to B is to D. Okay, so let's write that in a fraction form. So you have here A over B is equal to C over D. Then therefore, A over C is equal to B over D. So the numerators and the denominators. So try to think of the word alternate or alterando. Okay, so we're just using the alternate parts for this one. Okay, so for example, we have here, okay, so we have here 12 is to 7. Okay, so let's say for example, we have here 12 is to 7 is equal to 72 is to 42. Okay, or 12 over 7 is equal to 72 over 42. So using the Alterando property of proportion, we can say that, okay, so since this is A, and this is B, and this is C, and this is D, so therefore, we can say that, okay, we can write here A over C, so therefore we can say that 12 over 72, so this is A, and this is C, is equal to B over D. So this becomes, okay, 7 over 42. Okay, so let's check using our calculator. So 12 over 72 is equal to 1 over 6. Okay, and 7 over 42, okay, 7 over 42 is also equal to 1 over 6. And therefore, our proportion checks out. And therefore, the Alterando property is one of the valid properties of a proportion. Okay, so let's try to look at the third one. So we have there the componendo property of proportion, wherein A over B. Okay, so if we have an assumption that A is to B is equal to C is to D, or A over B is equal to C over D, then therefore we can say that A plus B all over B is equal to C plus D all over D. Okay, so let's try to use some examples for this one. Okay, let's say for example we have here 4 over 12 is equal to, okay, it's equal to 20 over 60. Okay, so let's try this proportion. So if this is A, and this is B, and this is C, and this is D, so therefore we can say that 4, okay, plus 12 all over 12 is equal to, okay, let's try to put here C, 20 plus 60 all over 60. Okay, so let's try to solve it over here. So this becomes 16 over 12 is equal, okay, 16 over 12 is equal to 60 plus 20, so that you're going to get 80 all over 60. And 16 over 12, okay, 16 over 12 is simply equal to 4/3, okay, 4/3. And also 80 over 60, that's also going to be equal to 4/3. Okay, so let's just double check that, and it's also 4/3. So there you go. So therefore we have proven also the componendo property of proportion.